Hello, my people. You're welcome back. It's another evening again. You're welcome to Oṣuṣu ti ilé ẹ̀kọ́ Yorùbá wa. Níbi tí a ti ń kọ́ gbogbo ẹ̀ka ẹ̀kọ́ ní èdè tiwantiwa, èdè kóòtù òjíire, èdè Yorùbá. Where we teach all subjects in our language. You know, at the same time, we still need to use it to introduce, to greet our people. On this mountain, we teach academically, spiritually, we teach. Yes. We thank God for the day. You're welcome. We have been on this particular course, circuit analysis. It's a course to deal with for we scientists, science students over there. Electrical person. You're welcome. Once again, whenever I have a call to serve humanity, I become psyched in serving humanity. Many outside there need to do the same, but there's no spirit in them to do the same due to the condition we have found ourselves, due to the environment that is not palatable, due to the free hand that is not given. Many are trying to serve humanity too, but they cannot do it because the environment is not conducive. Yes. Me that I'm carrying it is by His grace, because I'm made special. That's why I can embark on the journey of free doing for my people. That is it. The moment I have the call, the moment I'm being called to serve humanity, I become psyched. I become more happy. Yes. The environment is not conducive. We are there today. We are the professors. We are the doctors. Your country does not allow them to practice. The people of knowledge, your country does not permit them to excel. Many are there having such type knowledge, but just there is no spirit in them to overrun the condition, the situation, the constraint environment. The environment is so constrained. It's too stressful that you cannot withstand it. But by God's grace, because I'm made special, that's why I can confront the situation of this community, of this land, of the country, Nigeria. As I can confront it by His grace, for being made a prophet. For being made a prophet. That is why I can confront it. Because it's not easy. It's not easy. But when I'm doing something that sounds as if I'm serving humanity, no, I derive joy in it. Yes. That's why I can do what I'm doing. And I encourage you over there, whatever you know that you can do well, do it very well. That's the ability given to you by the divine. It's not by your parent. Divine giving. You're welcome. Still on our circuit analysis. My electrical students over there. Come closer again. Let us continue with what we have been doing. Here is another circuit before me. Let me have the circuit on board. It's already late. I came late. Yes, I just enter office now. After it already. But I think this particular work will take me just about 20 to 30 minutes. It's not as that lengthy. Now, let me have the circuit on the board. We see how it has to do with just like the one we treated yesterday, that has to do with SUPERNODE. SUPERNODE. Here is it. I come again. That which you know that you can do it very well. In order to serve humanity. Yes. Whatever you do today shall talk of you tomorrow. That is it. Circuit analysis. Application of SUPERNODE. We still need to apply SUPERNODE. Why? What is the question? Find the V, the voltage, this voltage, and the current, this current, in the circuit. Analysis of a circuit, it might be small here. You will be able to apply that particular small to any other one. Because in a system, in a circuit, in network topology, nothing is left out. Any knowledge derived shall be applied tomorrow. Whatever you get from here, you shall apply it in whatever you are doing in your classes. Whatever you are going to face tomorrow, you shall apply it. If you are going to teach others tomorrow, you shall apply it. No knowledge is lost electrically. Small one, we don't change it. Rectification is rectification. Amplification is amplification. They don't change. Direct current is direct current. Alternate current is alternate current. They don't change. It's permanent. Whatever you know today, let it be assimilated. It shall be useful for you tomorrow. That is it. What I knew yesterday is what I'm applying today. And the moment I'm applying it, I derive joy. Follow me. Find the V voltage along here. Correct here. Now, you can see the first is to examine the circuit. Examine the circuit. What are the inputs? What are the elements? What are the branches? You have plenty branches here. But here I can see node. I can see node here. I see node here. Connection of element. Connection of branches. Node. Can see node here. Node 1, node 2. Now, this node, there must be a voltage here. Voltage here. Node 1, node 2. Node 1. At this node, there was a voltage there. There was a voltage there. You are going to put it there by yourself. When you must have examined, look at watch out for the circuit. Now, all this area happen to be a node because there is no branch, there's no another branch here. That's why, just like the one I drew yesterday, they are referring to node. That means you are going to have in anywhere here, you are going to have your reference node. Anywhere here, you are going to have your reference node there. All this will now be non-reference node. That is it. And I talk about formation of SUPERNODE. Formation of SUPERNODE. How do we form SUPERNODE? Whenever we are given a voltage source connected between two non-reference nodes. This one has no any other element connected with it in parallel. Only the voltage source is standing by itself, but it's in between two non-reference nodes. That's why you are going to create an equation for it to help you out of the situation. Itself is going to produce a constraint equation which we need to solve in order to get the breakthrough. That's why you must have it so special. It's in between two nodes. In between two nodes, it must be made supernode. That area we made supernode. Now I'm going to redraw this circuit. It will come this way. To come this way like this. That's how to create a supernode. A supernode in between two reference non-reference node. That's how to create it. A supernode. The next thing now is to apply KCL. We need to apply KCL now. We are able to bring this thing out. We have mesh. Loops. Now, we are going to apply KCL in this area. Here it's 4 ohms. Here 7 volts. KCL. Apply KCL. To apply KCL to the node C1, here is the voltage source we are dealing with. We are going to deal with this first voltage source. It's not in between two nodes. It's standing separately. From this particular voltage source, current will move from there That's the first current 1. Current 1, we move from there. Now, here, current 2 will now come here. Current 2 will come there. Now, current 3 will be here. Here will now be current 3. That's what they said we should look for, current 3. Now, another current will go to this other line. That will be current 4. I4, current 4. Now, this is the movement of the current now. And KCL says, algebraic sum of current entering into a node. This current enter here. The one that enter happen to be the positive. That's current 1. The one that's now living, coming out of this place will be negative. But this particular one is equals to this one, this current 2, plus this current 3, plus this current 4. That's how to arrange them. Just learn how to arrange all these circuit solutions. You will get it. Very simple to follow. And when you are getting it, it will be giving you joy. That is it. We are not going to express this current in terms of the voltage, node voltage. Express the current voltage, node voltage. We are going to express that, but all this current now, all this current in terms of node voltage. That is it. Now I want to come to this side. We are going to get all this current in terms of node voltage. How do we get there? I treated the same yesterday. The current 1, I1 is equals to the I1 pass through here, through 4 ohms resistance. Will now be this voltage, and on this C1 divided by this 7 and on Z1 over 4. That's how to get that one. That's how to get that one done. Node, principle of node. Current move from higher from higher position to lower position. Move from here to here. That's why we are going to subtract difference between the two divided by the resistance. Now, that's from I1, I2. No time. I2, V1 to the reference node, which is 0. Reference node is 0. That is V1 minus 0 over 3 resistance. V1 minus 0, there's no point of writing 0 here. Now, we need to continue. We're talking about current 3. I3. V2 minus 0 over 2. Minus 0 over 2. As a point of writing over 2. V2 minus 0 over 2. We continue. Now, here we have a current 4. Current 4. Which current 4 is in this way. V2, that current 4. V2 over 6. That's it. We are now going to arrange them in form of this one. I've been able to bring them out. Arrange it in form of the equation. This is the equation we are going to use now. This current, everything will now be 7 minus V1 over 4 equals to V1 over 3 plus V2 over 2 plus V2 over 6. We are coming up. Step by step, just to understand the principle and be applying it. Very simple. But people will not like to sit down and study. They be giraffing. Do all you can. So far you have done what you could do. It's enough. But try your best. Electrical, circuit analysis. Very good subject per se. Now, what do we do? Multiply all by 6. The highest, it's not LCM, Abi. I don't know what they call it. All I know is that we have numerator, we have denominator. The biggest denominator, 6. Multiply all by 6. Yeah, that will be 3. 3 into 7 minus VI over, that will remain 2. Equals to, that is 2 VI plus, that is 3 VI, 3 V2, here will be 6, that will be plus V2. I multiply all these fractions by the biggest denominator by the 6. You have to bring it in this way. If you multiply that by 6, it will give you this thing. Now what remain there? Now remain here was 1, 3, remain 2. Now multiply by 2 again. Here will now remain 7 minus V1 equals to, here will be now become 4 V1 plus, here will be 6 V2 plus 2 V2. This one has to do with mathematics. Be very smart. V2 or 2. That is that. Now, to continue, let me come over here. And I'm going to use something. Okay, let me come over here. Let me come over here. Now, multiply this one out. 3 times 7, 27, I'll be 21. Minus 3 V1 equals to 4 V1 plus 6 V2 plus 2 V2. Now, we have a V2, 1, 1, 1, 1, 21. Take this one to this one, will that be minus 7v1 equals to 8v2. Now we have a minus 7v1 minus 8v2 equals to minus 21. Now multiply all through by minus. Now give us 7v1 plus 8v2 equals to 21. That's the first equation we can get. First equation. That's from the, we remove the supernode. As if we are no longer seeing it. It will be treated like that. Now I want to go and form another equation from that supernode or with the supernode. That's the next thing to do now. Now, let me rub here. That supernode, we are going to bring it out. It was here, which was 3 volt. It was 3 volt. It stood like this. That's the voltage source. And then the current move this way. 3 volt. We are going to form another equation with the supernode. Now, here is the supernode. 3 volt. Then we are going to make broken lines to represent its own area. We are going to form supernode with the every branch connected to the branch connected around the supernode. We have to form another equation with that particular supernode and the branch connected to it. And this is the branch connected to it. Now, here we have a positive, because here is where we have our reference node. Will be negative, positive. And now we are going to create our mesh. Movement of the motion through the loop. That's what we call mesh. You create it like this. Then you like your own counterclockwise, but I make it clockwise. Now, and you know the principle that guide this movement, this motion. As we start here, it will be negative. We are going to have a negative 3 volt, negative, because that have to be the algebraic sum of voltage around the loop, around the circuit. Now, as we come here to, here is V2, here have to be V1. That's node 1, node 2. In between we have the supernode. That is 3, negative. Here, our motion is like this, and the current here is moving like this. I mean, current gain there. I mean, voltage gain there. Voltage gain. That's why we are going to have plus V2. We have plus V2. Then we have voltage gain. Now, as we are going this way, our motion is in the same direction with the current moving there. I mean, voltage loss. That will be negative V1. All will now be equals to 0. That's an equation you can get from there. Very cheap to follow. You don't need to be saying you want to go and look for node 2 node. No, it's not done in that way. That's why we say that that particular supernode will produce a constraint equation to solve. Now to get the right answer. This is the equation that it produced. Now we are going to bring the equation to here. What do we have here before? We are having now here. Let me resolve this one more beyond this. Let me try to look for V2 here. V2 here will now be equals to 3 plus V1. I want to get this V1. I don't want to wait for V2. Now since we have got V2 here, 7V1 7v1 plus 8 into v2 here. 3 plus v1 equals to 21. That is it. 7v1 plus 24 plus 8v1 equals to 21. Equals 21. Now, v1 plus v1, that is I think that is 15. 15 v1 equals to 21 minus 24, which will be equal to 3. Now, 15 v1 equals to 3. v1 now will now be 3 over 15, which is equals to 3 divided by 15. 0.2. 0.2. I think we are looking for voltage. Volt. 0.2 volt. This V1 is 0.2 volt. V1 0.2 volt. This V1 0.2 volt. Nobody can argue it. Any question, just do it like that. You have to go. Now, what are we looking for again? This current. This current. And then we are giving 2 ohms. 2 ohms. What would that be the current? Let me rub here. Now that we have gotten V1, just to get to V2 and get this current. We have got the V1 to get V2. Why we cannot have it parallel is because of that particular voltage here. It doesn't go like that. It must be found separately. Now that time we had V1 to be equals to and V2 to be equals to 3 plus V1. That was the V2 we had. 3 plus V1. Now, and we have gotten V1 to be 0.2. V2 will now be 3. V1 was minus 0.2. V2 will now be plus minus 0.2 will now be minus 0.2. Which is equal to 3 minus 0.2. 3 minus 0.2. 2.8. 2.8. Now, V2 is 2.8. Automatically, this current, that I3 is equal to V2 over 2, which will now give us 2 divided by, I think that is positive. 2 divided by 2.8 divided by 2, which is now equals to 2.8 divided by 2. 1.4 amps. 1.4 amps. What you need to gain from this one is that we have what we call supernode. Whenever you are giving that type of a circuit, whereby we have a voltage source connected in between two non-reference nodes. Think of a supernode to solve the problem. Go for your KCL, go for the KVL. Here is where we have KVL. Here is KVL. We apply KVL here for mesh to get that particular V2 equals to 3 plus V1. Then you arrange it, you get they are finishing. But take note of the steps to follow. Thank you. You are there. Extend the regards. Let others know. share it, comment, follow the matter, and comment. Let others know we have done this. No time on our side. Yes. As from next week now, I will go back to my proper class. We have to be physics in Yoruba. Yes, physics in Yoruba. That will be as from next week. But I will still have to check others, the other questions on ground. Let me still come up with some. Thank you for being here.